असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्युर्मा अमृतं गमय.
Hello everyone, hi. So happy National Mathematics Day. National Mathematics Day is celebrated in India and all over the world annually on December 22nd to honor the birth anniversary of the renowned Indian mathematician Srinivasa Ramanujan. This day is an opportunity to recognize the importance of mathematics in shaping our understanding of the world and also to search for new Ramanujans in this big world. So speaking of which, the greatest attraction of today's event is our chief guest and speaker, Professor Ken Ono. So he's so many things, and he would be the best person we ever have for this Ramanujan event because his life has a close connection with the man who knew infinity. And also, he was a producer of the Ramanujan film, The Man Knew Infinity. All of you, I'm also super excited for this national webinar. This is the 10th one in the webinar series, Math Ecstasy, organized by Maths Aspirants Groups. About this group, it was started as a WhatsApp group in 2017 by Dr. Vinod Kumar, Associate Professor, TMG College, Tirur, Kerala, India. And now it's a big growing mathematical community that actively conducts so many academic programs and problem-solving sessions, and also preparations for exams to premier institutes, and also preparing candidates for research and so on. Okay. And also we have Dr. Bijumon, who is Associate Professor, MG College, Iritty. He is with us for all the technical support. And I am so happy that I'm also part of this group from the starting itself, because it started as a WhatsApp group and now it has members, maybe I can say all over the world, because we have so many members. Once we have a program, we have registrations from so many countries, and we have successfully run all these national webinars till now. So, and also it's not possible to mention all the names, but with lots of love, I would like to remember everyone who is working selflessly for this community. So I can't say all the names, but seriously, I'd like to say all the names. So thank you, each of you, for your presence and patience. Now, without any delay, let's have a blast with our dear Professor Ken Ono. So firstly, let me welcome Dr. Vinod Kumar for sharing his wishes for this program. So welcome, Vinod.
Dear friends, National Math Day greetings to all. Today is very special in the journey of Math Aspirants Groups, as we had blessed to have Professor Ken Ono in our platform to talk on Ramanujan. And all of us know he is the most apt person to speak on Ramanujan. I'm really indebted to you, sir, for accepting our invitation and joining with us. I would like to thank Professor Ambat Vijay Kumar for helping me to connect with Professor Ken Ono. I'm sure that the coming hour will be of academically a rich academic experience for everyone gathered here. Thank you, everyone, and hearty welcome everyone to this event. Thank you.
Now, let me welcome Dr. Professor Ambat Vijay Kumar, Emeritus Professor, CUSAT, who will give you a nice and crisp introduction to our chief guest, Professor Ken Ono.
I have great pleasure to introduce my good old friend Ken Ono, who did this PhD from University of California, Los Angeles, and he's currently a professor affiliate of statistics at the University of Virginia, USA, and also professor of data science by courtesy, and STEM advisor to the provost, and Marvin Rosenblum professor. Recipient of several awards. He was also awarded FE Silver Award 2023 and University of Chicago Alumni Award for Professional Achievement 2023 and honorary professorships at Mathematical Sciences Institute, Belgavi, Indian Institute of Technology, Govt, and many other institutes. He is also a college faculty fellow of the University of Virginia and Fellow of the Shannon Center for Advanced Studies and Distinguished Spotlight Researcher Award. Among several editorial responsibilities, he is an editor of the Annals of Combinatorics, Bulletin of the American Mathematical Society, Communications in Number Theory and Physics, Electronic Journal of Combinatorics, R.D. Ramanujan Journal, and International Journal of Number Theory. He is a member of the Asian American Scholar Forum and an advisory board member of the National Security Agency and Board of Trustees of AMIAS, Institute for Advanced Study. His famous contributions to media and outreach include host of the podcast Who's in STEM 2023 and Science India TV program and Spirit of Ramanujan Global STEM Talent Search program. He is a multifaceted personality, as you can see, and we are happy that he accepted our invitation to deliver the National Mathematics Day Lecture 2023 on this special day, 22nd December 2023. With these words, I invite Professor Ken Ono to start his lecture, The Man Who Knew Infinity. Thank you.
It's early morning for me on December 22nd. Today is National Mathematics Day in India, but I want to assure you from my perspective, today is the World Mathematics Day because on this day in 1887, Ramanujan was born. And I have been following, like many others like me, I have been studying his story. I've used his personal life as inspiration for me and my students. And his mathematics has guided my way and has led the way for very distinguished scientists from, of course, mathematicians to physicists to many, many different areas. And so it's a great honor for me to celebrate with you his birthday, National Mathematics Day in India. And the lecture I would like to give is called Why Does Ramanujan, the Man Who Knew Infinity, Why Did He Matter? And although this is the kind of talk that I've given many times, the answer remains the same. And there are many answers. The story is still quite fresh in my mind because it's a constant stream of inspiration that I get from his story, from his mathematics, and from events such as this. So I can give you as an example, we have a new postdoc at the University of Virginia. He comes to us from India. His name is Ajit Singh. He's on the webinar, and he himself is inspired by the great mathematics produced by Ramanujan. And because of that story, he's come to the United States and he's studying with us in Virginia, giving rise to further collaboration and further expansion of Ramanujan's ideas. And so every time I give lectures like this, there are some new stories that I can tell. And in this case, it's growing international partnership, although I'm unable to be with you in person in India. So I first learned about Ramanujan on a day I remember. It was April 7th, 1984, Saturday. And 1984 was a very long time ago for probably most of the attendees of this webinar. For me, I was a high school student. I was in 10th grade as a high school student growing up in a suburb of Baltimore, Maryland. And on this day, this letter arrived at our house. And let me read to you what this letter says. The letter reads, and it was written to my father, although as you can see, it was written to anonymously to many people, my father just being one. The letter reads, Dear Sir, I understand from Mr. Richard Askey, Wisconsin, USA, that you've contributed for the sculpture in memory of my late husband, Mr. Srinivasa Ramanujan, and I'm happy over this event. I thank you very much for your good gesture and wish you success in all your endeavors. Yours faithfully, S. Janaki Amal. So for me as a high school student, way back when, this letter was very strange. First of all, it wasn't addressed specifically to my father. It was addressed to a group of mathematicians who had made donations to support the commissioning of a sculpture in Ramanujan's memory. So I already thought that was strange. But what was stranger on top of that was the letterhead of this paper. There was an image of a man, as you can see here on your screen. He lived a long time ago. He had died in 1920. And in the upper left-hand corner, you see S. Janaki Ammal with the subtitle, Widow of Late Srinivasa Ramanujan, Mathematical Genius. And as a 10th grader growing up in the United States, I'd never heard of Ramanujan. And so I found this to be quite a peculiar letter. Except my father, who was a mathematician, a professor at Johns Hopkins University, was deeply moved by this letter. And in fact, this letter brought him to tears. And what my father told me upon the receipt of this letter was a most lovely story. And as he told it, he said, "You're not going to believe this. It will sound like a fairy tale. But long ago, out of the country of India came a mathematical genius named Ramanujan. And he was an amateur, unlike me, my father, and the mathematicians that I had come to grow up to know as being raised in a community of mathematicians. Unlike the mathematicians that I was around, Ramanujan was an autodidact. He was amateur. The ideas that he came up with, he even believed were given to him as gifts from an Indian goddess. And for me, that was shocking. And then on top of that, my father said, and what you won't believe is that the mathematics that Ramanujan left behind still befuddles the best mathematicians to this day, over 60 years later. And so the story went on. My dad went on to explain that Ramanujan was a 2-time college dropout, and that he himself, as a starving Japanese mathematician in World War II era Japan, had gotten inspiration from Ramanujan. So I quickly learned that perhaps everything about my family had somehow been inspired by Ramanujan, and my father, like one of the many mathematicians in the world, ended up giving a financial gift to help commission this statue. Even this part of the story I found to be quite beautiful. You see, by the early 1980s, the mathematicians of the world were getting ready to celebrate the 100th anniversary of Ramanujan's birth. And by 1984, or maybe say a year before that, the growing expectation of the events that would surround Ramanujan's birthday became, I think, national news, or certainly reached the level of the attention of reporters in India. And so what inspired this sculpture is that a reporter from the Hindu, which I understand reported on this lecture today, so very ironic, a reporter from the Hindu tracked down Janaki Ammal, the living widow of Ramanujan, the author of this letter. And apparently he wrote an article about her life and her memories of Ramanujan. And quite beautifully in this article, she said, well, when my husband died in 1920, the government promised to erect a statue in his honor. And where is that statue? So Dick Askey, a professor at the University of Wisconsin, somehow got a hold of this article in the Hindu and said, we, the mathematicians of the world, so deeply inspired by Ramanujan, we will take it upon ourselves to give Mrs. Ramanujan the statue. And that's yet another beautiful layer on top of all of that. And so hence the letter. Janaki Ammal wrote these letters to the mathematicians who contributed to this gift. So try to imagine what I was thinking as a 10th grader. As a 10th grader, I was very good at mathematics, but I didn't like mathematics. For me, mathematics meant tests. It meant the pursuit of arithmetic and computational perfection. It wasn't the stuff of art. It didn't seem beautiful. And so this letter and the stories that my father told me came as a huge surprise. And perhaps the most important surprise here was that my father said that Ramanujan was a 2-time college dropout. And yet, despite that label, he was his hero. He was the hero of mathematicians around the world. And as a 10th grade high school student, I took quite a bit of hope in that, because then I recognized that maybe the mindless pursuit of grades, test scores, wasn't as important as we were told or came to believe they would be. And that was very important for me. So as a 10th grader, without knowing anything about any of Ramanujan's mathematics, just these stories alone, and hearing from my parents that the quality of one's character and the importance of one's achievements matter more, and the story of Ramanujan is what made it very clear to me. So if what I just described to you is interesting, together with Amir Excel, who was a well-known science writer in the United States, he passed away in 2015. Amir and I wrote a book called My Search for Ramanujan, which in part tells the story of Ramanujan, but also tells the story that I think is important for me as a professor in the United States. It talks about the inspiration that one gets from Ramanujan's life and trying to follow in his footsteps, both as an iconic figure in science and as a producer of formulas that we feel the need to figure out. So this book came out in 2016, My Search for Ramanujan. And if that part of why Ramanujan matters speaks to you, I encourage you to read it. So again, this lecture is called Why Does Ramanujan, the Man Who Knew Infinity, Matter? And I already offered you a first answer. For students, for young people who are uncertain about education and the importance of courseworks and exams versus actual achievement, the story of Ramanujan matters. Now, a few years before we wrote that book, perhaps the most remarkable event in my life occurred. I was invited to be part of the crafting of the film called The Man Who Knew Infinity, that was based on this lovely book called The Man Who Knew Infinity, written by MIT professor Robert Kanigel. And at first, my job on the film was to provide artwork, formulas that would appear in the film. And over a short period of time, because of my knowledge of Ramanujan, I became, together with Manjul Bhargava, one of the main experts. And so I ended up traveling to the filming. I worked with the actors. Here you see in the left a picture of me when I still had hair, coaching Dev Patel, talking about some theorems in complex analysis. If you know, it's called the Cauchy integral formula. And on the right of the screen, you see the movie poster that we use in the United States. And so you could see some of Ramanujan's handwriting. That's the white scrawl, Dev in the foreground. And in the background, very famous Academy Award-winning actor Jeremy Irons, who played G.H. Hardy, who I will tell you about. So it was a remarkable experience. After my time as a 10th grader, being inspired by the letter of Ramanujan, I went to college at the University of Chicago, where I struggled quite a bit, but the story of Ramanujan inspired me and it rescued me when I needed it most. I ended up earning a PhD at UCLA, as was mentioned before, and I chose to work on mathematics that was inspired by Ramanujan's letters and his papers. And it was a very exciting time when I was a PhD student, because the book, The Man Who Knew Infinity, on which the film was based, came out when I was a graduate student. And together with my advisor, we devoured the book, which filled in lots of details that I had no clue about. And so all of these events just somehow came together, and it was so exciting to be invited into the film project when the book and the man himself played such an instrumental role in everything I had become. So I'd like to share with you the trailer of this film. If you have never seen the film, or even if you have, I hope you enjoy the trailer.
What do you see?
Sand.
Imagine if we could look so closely, we could see each grain, each particle. You see, there are patterns in everything.
Integrals, infinite series.
I've never seen anything like them.
From an Indian clerk, ill-educated in Madras, I would very highly value any advice you give me.
Letter for you. Postmarked England.
Yours truly, S. Ramanujan.
What does the S stand for?
You can ask him yourself.
You intend to invite him here?
Don't forget me. I could never.
Are you Ramanujan by chance? Oh, don't be intimidated. Great knowledge comes from the humblest of origins.
For the good of everybody, you should attend some lectures.
But I'm here to publish. The letter only contained a small sampling of my discoveries.
This will take a lifetime.
Maybe two.
We need proofs of your work.
But they are right, sir.
I hadn't completed that proof. How do you know?
I just do.
You don't pull a stunt like that in my class.
Now get out!
How do you know that theorem?
It came to me. These steps you want, I do not know how to do.
Where do you think you're going? This is our home.
Don't you know what I've given up to be here? I have nothing. You wanted to know how I get my ideas. God speaks to me.
There are no proofs. We're just supposed to take him at his word?
No, you're to take him at mine. Why do you do it?
Because I have to.
There are no proofs that can determine the outcome in matters of the heart. We are merely explorers of infinity in the pursuit of absolute perfection.
I owe you so much.
No, no, no. It's I who owe you.
So there you have the trailer. If you haven't seen the film, I hope you have the opportunity to see it perhaps online, a streaming service. I think it's a beautiful film. And as I said earlier, it's perhaps one of the most extraordinary projects I've ever been part of in my life. So this lecture, again, is entitled, Why Does Ramanujan, the Man Who Knew Infinity, Why Does He Matter? I've offered you a couple answers. Let me offer, or at least expound on one of these answers by telling you the story behind this picture. So you might recognize where this photograph was taken. If not, I assure you that if I were to take a different vantage points where more of that white building was exposed, you would recognize that building at first glance. And of course, if you read the caption, you can probably tell that I'm speaking of the White House. So in this photograph, taken shortly before Halloween of 2016, you see that on the left is France Cordova, the former director of the National Science Foundation. Immediately to her right is DJ Patil, who was the first chief data scientist for the United States of America. He was part of the Obama administration. Immediately to his right is me. I still had a little bit of hair left. And then to my right is Jeremy Irons, the actor who was in the film. So why am I showing you this photograph? Well, first of all, I assure you that France, Jeremy Irons, and DJ Patil, they are big deals. And I mentioned a moment ago that this photograph was taken at the end of October in 2016. So what happened shortly after this day, the day this photograph was taken, there was a national election, a presidential election in the United States. And it is tradition that the outgoing president, in this case, Barack Obama, it's outgoing tradition that the outgoing president hold a week of transition training events for the teams for the leading candidates to be the next president. At that time, Trump and Clinton, Hillary Clinton. And what the Obama administration suggested was that since the last day of this week of events, which was meant to train the incoming candidates about the workings of the federal government, they came to the White House. The last day was about science. It's about the research foundations. It was about the National Science Foundation, the National Institute of Health, the Department of Energy, right? These were the major national funding agencies for science in the United States. And the last day was devoted to training sessions and panel discussions about these entities. So I was invited by France Cordova to participate in a discussion about funding that's offered by the National Science Foundation. And what President Obama suggested was that after a long week of activities, there should be a social event. There should be a social activity capping off this weekend, this full week of events for the Trump and the Clinton campaigns. And he said, why don't we screen the film, The Man Who Knew Infinity, at the White House? So what is this photograph? This photograph is from us right before the screening of the film. We gave a presentation to the citizens of the United States, and we gave a question. And perhaps you can read the whiteboard. The question is, what is the smallest number that is the sum of two cubes in two different ways? And if you know the story of Ramanujan, you know that it's connected to Ramanujan because Ramanujan famously knew that the answer to this question, or knew the fact that 1729 is the smallest number, which is the sum of two cubes in two different ways. Now you might ask, why would the President of the United States want to screen a small independent film at an event as important as a lead-in to the next presidential election? And this was his very beautiful point. His point was that even back in 2016, we all knew that mankind faces many significant challenges. Many we still face: the pursuit for green energy, climate change. We seek a cure for cancer. We wonder about extraterrestrial intelligence. Are we alone? There are many significant challenges and scientific questions that we face. And this came even before COVID, right? And the onset of artificial intelligence, AGI, that we talk about so much today. And what Obama pointed to was his concern that he saw storm clouds on the horizon, namely that we were beginning to notice that the world was becoming polarized, right? It was more about individuals, more about political parties. It was more about this country versus that country. And for Obama, the film The Man Who Knew Infinity had one very important point. And the point is that the two main protagonists, Ramanujan from India, G.H. Hardy, who I'll tell you about in a moment, the distinguished professor in England who brought Ramanujan to England, were two very different people. They were from two countries that didn't really get along, right? India was subjugated as a colony in the British Empire. They were not equals. And on top of that, Ramanujan was a two-time college dropout, and Hardy was the most distinguished professor you could think of at Cambridge in mathematics. But together, despite their very different backgrounds, their different nationalities, their very different cultures from which they came, and their very different views of spirituality. Hardy was very much an atheist. And as you know, Ramanujan was deeply spiritual. Despite every reason that these two men should not have been able to communicate, they did come together and produced amazing mathematics. And what Obama wanted and viewed as the main story of the film was the point of international collaboration, and that there was a lot that we could learn from that part of the Ramanujan story. So that is my second answer to you for why Ramanujan matters, because his example of international collaboration speaks to policymakers. In fact, isn't that why there's a National Mathematics Day in India? The policymakers in the country of India have proclaimed today National Math Day because it marks Ramanujan's birth. So here is evidence, at least from North America, the United States, that we too recognize the importance of the Ramanujan story. And maybe we can restore some value in science and education at a very difficult time. So I'd like to tell you my perspective about Ramanujan's life, because I've discovered that when I speak to audiences in India, my interpretation is often illuminating. Right? I grew up in the United States. I'm Japanese Japanese American. I'm Japanese in origin. So nothing about my childhood and prepared me to understand anything about Ramanujan's background. So very briefly, Ramanujan's life summarized is as follows. For me, Ramanujan was born in 1887 in very, very, very far away southern India, the state of Tamil Nadu. Although I've traveled to India many times, make no mistake, every time I visit, it's an adventure, right? The cultures are very different. The colors are so brilliant. It's very much unlike anywhere I've spent most of my life. Ramanujan was born a Brahmin, and that's not unusual for me. Most of the Indians I encounter in the United States are Brahmin, largely due to their interest in education. I learned that Ramanujan was an outstanding student as a young boy. He won academic awards and even won scholarships to college. He did that twice. And what's particularly striking, and I'd like to emphasize, is that Ramanujan not only was, I claim, an autodidact and self-trained. I have to add several layers to that description. Ramanujan did much of his mathematical exploration on his own at a very early age, and by the age of 13 had discovered much of trigonometry by himself. That is just so difficult for me to understand, because as a student of mathematics, as a child, it was all about, I need to learn these books, I need to attend my lessons, I need to do my homework sets, and that was the process by which mathematics, I thought, was done. And it wasn't until my late 20s, even after I had my PhD for many years, that I recognized that actually the spirit of doing mathematics is much more of a creative process. It's much more like an art. But of course, for Ramanujan, this is something he understood from the outset. As a young boy, he received this book. It was a gift from a friend. Here is a scan of the cover of the book by G.S. Carr. It's called A Synopsis of Elementary Results in Pure Mathematics. And in A Mathematician's Apology, that was written by G.H. Hardy, this book is described as follows. It contains enunciations of 6,165 theorems, systematically and quite scientifically arranged, with proofs which are often little more than cross-references. So in other words, it was really just a list of theorems, not even an amazing book in any other way. Okay. How would you think of this book? You'd think of this book as a tutor's book. If you were preparing for a college entrance examination and you wanted a repository of all the formulas that you might need or have access to on the exam, well, this might be the book you would use. It wasn't really a textbook by any means. But the sheer volume of the many formulas and results that Ramanujan found in this book clearly inspired him. It ignited his passion for mathematics. And as an amateur, as a self-trained student, he thought this was how mathematics should be done. And so following the style that he found in this notebook, in this book, he started recording his own formulas in his own notebooks. You can yourself see these notebooks. So here's a photograph from, I think, 2013, 10 years ago. You can say I've aged a bit. This is a photograph of me with my good friend, Professor Raghuram, who you might know. He was the former director of the Mathematics Institute in Pune, nicer Pune. Here we are at the University Library in Madras, University of Madras Library, now Chennai. And you can ask the librarian to bring out for you Ramanujan's notebooks. And here we are flipping through the pages of Ramanujan's notebooks. I've done this a couple of times. It's a very special experience. And if you have the opportunity to do it, despite the fact these pages have been reproduced in print and online, I do recommend that you go see them. It's really kind of an emotional experience if Ramanujan is one of your heroes. So as a young boy, as I mentioned, Ramanujan became obsessed with mathematics. Because of this obsession, he started to spend all of his time doing math. And as a result, he wasn't able to focus on any of his other studies. And that turned out to be the reason that he flunked out of college. And he did this twice. For me, as a Westerner, growing up in the suburb of Baltimore, Maryland, not far from Washington, D.C., I was struck by tales of and stories of Ramanujan doing mathematics in temples, in Hindu temples, where he would write down formulas on his slate, and when he was pleased with the formula, he would then record them in his notebook, all in this environment that was so foreign to me, with drums and chanting in the background. I often visit, as I said earlier, Kumbakonam on this day, National Mathematics Day, and I always make it a point to visit the Sarangapani temple, the street on which Ramanujan was raised. And every time I go, I usually go with fellow mathematicians. We are blessed in a puja ceremony, and in walking carefully around the interior of the temple, I always pause and think that 100 years ago, or 110 years ago, a century ago, Ramanujan sat on those very stone floors with his slate and his notebook, and it gives me shivers. It's really kind of an amazing thing. So as a two-time college dropout, he needed help. He ended up securing work as a clerk at the Madras Port Trust. I think that's important. For me, as a young student in college, I found it very encouraging. It gave me hope that he had supporters that, although didn't make him wealthy, of course, helped him stave off poverty. They continued to support his belief in his mathematics, despite the fact that essentially no one around him understood or comprehended the value of the work that he was producing. I think there's a lot that we can learn from that. In today's day and age, if you're a two-time college dropout, you know, could you imagine people helping you out, encouraging you to continue on your way in your mathematics? That's hard for me to see how that would happen. And quite frankly, I worry about that, because where are we going to find the Ramanujans of the future? Those who have such creative ideas that mankind needs to make advance in science, right? These kinds of geniuses are rare, very rare, very, very rare. So Ramanujan was encouraged to reach out for help, because he might as well have been living on a mathematical desert. And his supporters encouraged him to write mathematicians in England. And one of the letters was sent to G.H. Hardy, who was played by Jeremy Irons in our film. And the letter that Ramanujan wrote to Hardy begins with these very famous and beautiful words, very humble words. I beg to introduce myself to you as a clerk. I've had no university education. I have not trodden through the conventional regular course, but I'm striking out on a new path for myself, and the results I get are termed by local mathematicians as startling. And if you've never seen some of the mathematics that was in the correspondence that Ramanujan had with Hardy, let me take a moment to share with you what this famous mathematician Hardy received in the form of formulas in his correspondence with Ramanujan. So before I show you some of those formulas, here's some photos. On the left is one of the few photographs of Hardy that survived to this day. And on the right is Jeremy Irons when in a pose where we asked him to replicate that in this picture. And I think he did a great job. What was in the letter that Ramanujan wrote to Hardy? Well, there are several letters that Ramanujan wrote. And the first thing I want to say, which you probably picked up from the trailer, is that there were no proofs of any kind, right? In mathematics, you can make as many claims as you would like, but these claims must be held accountable. You have to give arguments, reasons, or explanations, what we call proofs. And one of the claims that Ramanujan made in his correspondence with Hardy is on the screen here. It's crazy. It's the claim that 1 plus 2 plus 3 plus 4 plus 5, the sum of the positive integers, it's not infinity. It's not even positive. He claims it's negative 1/12. And at face value, we know this to be wrong. But this is part of the genius in Ramanujan, that he was so far ahead of most of the people around him that the mere use of the equal sign meant something different to him than it would to you and I. If I say that 1 + 2 equals something, we know that that would have to be 3. Equals means that the two expressions that are separated by the equal sign represent the same value. But to Ramanujan, that was not the case. To Ramanujan, it meant that there was some relationship relating the left-hand expression with the right-hand expression. And if you're familiar with the work of complex analysis and maybe the work of the famous Riemann on what's called the Riemann zeta function, you would know that this claim isn't completely false. And in fact, by means of what's called the analytic continuation of the Riemann zeta function, you could even argue that this statement was true. You see, the Riemann zeta function sums up powers of integers, and in this case, sums up the first powers of all the integers. And the Riemann zeta function evaluated at 1, which would be like summing up the first powers of these numbers, does take the value -1/12. That is a true statement. Okay, and if you were to learn, if you don't know this theory, if you were to learn the precise mathematical description of what I just described, you would know that this observation is incredibly brilliant. This observation would have only made sense by the late 1800s, and Hardy, as one of the top analytic number theorists in the world, would have been very aware of that. He probably would have been one of maybe 40 or 50 people alive aware of it. And so this observation would have been stunning to Hardy. So in that sense, Ramanujan finally had found someone who understood the genius in the formulas. Now, I don't want to mislead you. Many of the formulas that Ramanujan claimed were already well known to Hardy and would have been unexciting. Some of them actually were wrong, but not terribly wrong. There was some accuracy in them, again, in the sense that to Ramanujan, equal means there's some beautiful relationship between the quantities, but perhaps not equality on the nose. So how did Hardy respond? Hardy responded by inviting Ramanujan to study with him in Cambridge. At first, Ramanujan did not accept the invitation, but Hardy was quite insistent. He wanted to see the proofs, and there's a beautiful story about how Ramanujan ultimately agreed to take the very long voyage at the time. In fact, even today, it's a long voyage to England from India. Now, back then, it was by boat, multiple boats, and it was at great peril. But eventually, Hardy convinced Ramanujan to make the long trip. And this is where the rest of the story and most of the film, The Man Who Knew Infinity, takes place. Together with Hardy, Ramanujan wrote 30 papers, some with Hardy, and they covered many important topics. And I want to emphasize that this work was done at a very difficult time. And by difficult, I don't mean that Hardy and Ramanujan proved great theorems in the absence of computers, in the absence of a large library, in the absence of the developments of mathematics that have followed them. Hardy and Ramanujan did their work together at a difficult time because of the racism that Ramanujan endured, and of course the difficulties of World War I. Cambridge University was not in session when Ramanujan was there. The young men that were ordinarily students at Cambridge were off in France and Belgium fighting a world war. So the students that Ramanujan encountered on a regular basis were casualties. They were victims. They were patients at the hospital that were the makeshift hospital that Cambridge University became. As a vegetarian, Ramanujan couldn't eat the English food, although, and as anyone who's been to England will now tell you that, well, the English food is basically Indian food today, or somehow modified Indian food. Chicken tikka masala, which is called Indian food in much of the world, is Indian, at least in origin, in terms of the spices. But back then, over 100 years ago, it would have been very difficult for Ramanujan, almost alone in England. But despite these hardships, as I mentioned, Ramanujan wrote 30 papers. And because of the importance of these papers, he was the first Indian scientist elected Fellow of the Royal Society. He was elected Fellow of the Royal Society in the year 1918. I'd like to point out that the year 1918 was 100 years before the year 2018. So I don't say that to be funny. You know that 1918 plus 100 would bring you to the year 2018. But I point that out because 2018 was not that long ago, just 5 years ago. So what happened 5 years ago? Well, 5 years ago, the Royal Society reached out to me. The president of the Royal Society at the time was Venki Ramakrishnan, and I think that is a name that you know. He is from southern India himself, not very far from Kerala, and he won the Nobel Prize for his groundbreaking work on the chemistry of RNA. And in 2018, he was the first Indian-born president of the Royal Society. And he reached out to me and some of my mathematical colleagues, said, we need to celebrate and honor the 100th anniversary of Ramanujan's election as Fellow of the Royal Society. And we did. In 2018, leading mathematicians, physicists, and computer scientists descended on England, and we had a ball, a conference, a symposium, where we recognized and honored the advances that had followed since the time of Ramanujan's election. And one of the most amazing, I think, realizations of the event was that although Ramanujan's work earned him a fellowship way back in 1918, perhaps his most important contributions were the result of the 100 years of science developed by researchers around the world trying to make sense of the notebooks he left behind. And I think there was absolute unanimous agreement that that body of work, the body of work that he inspired, was even more extraordinary than already the extraordinary works that earned him a fellowship. And so there was no question that Ramanujan was someone to celebrate. You see, the Royal Society elects fellows all the time. It's not in the business of having conferences to recognize the 100th anniversaries of their elected fellows. If they did, there would be no time for the business of science. So this was a major thing. So as I think you all know, Ramanujan fell ill during his time in India. That's related to the famous 1729 story. And he returned to India a year later, 1919. And he would die a year after that in 1920. On April 20th of 1920, he died, and he was only 32 years old. Despite his failing health, he continued to produce incredible mathematics from his deathbed. You may have read news reports or read articles about Ramanujan's theory of Mach theta functions. That's work that Ramanujan was working on in the very last weeks of his life. And those works played a very important role in my career 100 years later, in around 2010, together with some of my collaborators. We studied very deeply Ramanujan's Mach theta functions. It's now become a theory. We now call that the theory of Mach modular forms and harmonic mass forms. And these objects play a very important role in string theory, in the pursuit of quantum gravity. As abstract physics, this doesn't get more abstract than that. I hope you enjoy the fact that the study of black holes now makes critical use of the formulas that Ramanujan wrote from his deathbed. I'd like you to shudder to think where we would be if Ramanujan had not written that work, if he had died a few months earlier. Where would we be in our understanding of multi-centered black holes and black hole entropies? We would be very far behind. And so that's another story we learned from Ramanujan. Not only was Ramanujan important as a role model for students, as a role model for public policy makers, inspiring international cooperation. Not only was he important for the mathematics he produced, he was also important in that his mathematics has inspired some of the best scientists, the best mathematicians, the best physicists of the last 100 years. Quite frankly, if Ramanujan's letters and his notebooks had not survived, the loss in science is something that I today could not fathom. The things that I think about on a daily basis would not exist. So that would be like an alternate universe. And I hope you truly appreciate the depth and the gravity of how I say that. It would be a world I couldn't understand. As an analogy, it would be something like, where would we be now if people had not yet discovered electricity? For me, in the mathematical world, it would be something like that. So I do want to speak about some of Ramanujan's mathematics on an untechnical level, and I also want to explain why Ramanujan should be thought of as the man who knew infinity. You see, when Robert Kennegal first penned the title, The Man Who Knew Infinity, he thought it was quite poetic, but it wasn't really scientific or mathematical in origin. And when we're filming the film, The Man Who Knew Infinity, I was asked, actually it was the first catch party the night before the first day of the shoot. I was sitting across from Dev Patel at this little restaurant, which we had taken over. The entire production crew had taken over this restaurant, and Ed Pressman, the executive producer, asked me to give a little speech as the scientist in the room. And I told them why I thought Ramanujan was the man who knew infinity. So let me try to briefly recount for you what I said that day, because it involved one of my favorite objects, the partitions. So the partitions in number theory are objects that you can play with once you know how to add and count. So the stuff of child's play. And there's one function, my favorite, called P, invented by Euler, that counts the partitions. So on this slide, you can see my remark. We say that P of 4 equals 5, since we can partition 4 in exactly 5 ways. So you see in that block that I'm representing the number 4 in all of its additive ways up to reordering. We don't think of 3 plus 1 and 1 plus 3 as 2 different things. So if you count up the ways, there are 5 ways of assembling the number 4. And if you compute this function at other spot values, you'll get numbers like this. There are 22 partitions of 8. 8, 7 plus 1, 6 plus 2, 6 plus 1 plus 1. Those are the first 4. And by the time you get down to 8 ones added up, you will have made 22 partitions of 8. So whenever I show numbers like this, if you've never seen this kind of thing before, you're probably shocked. Are there really 230 ways of manufacturing 16? Are there really 8,349 ways of making 32? And this unpronounceable number of ways of making 256. This is a function that is easy to describe, but very difficult to calculate. And perhaps the most famous theorem that Hardy and Ramanujan proved together was what we call this asymptotic formula. So if you want to get a very good guess to how many partitions there are of n, P of n, you'll never get the exact right answer by their formula, but they came up with this very obnoxious looking function. 1 divided by 4n root 3 times e to the pi root 2n over 3. If you plug in numbers for n into this formula, that involves the obnoxious numbers e and pi. Numbers are obnoxious when you have to represent them by symbols, right? Pi and e. People even memorize digits of pi and e. It's because it's a horrible number, but beautiful in application. What Hardy and Ramanujan proved is that P of n is very, very close to this obnoxious expression on the right. So although the expression on the right never gives the right answer, here's a beautiful fact. What this tilde symbol means is that if you were to divide the right-hand side into the left and plug in larger values for n, you would find that this converges very rapidly to 1. In other words, asymptotically, the right-hand side becomes more perfect the larger n gets as n approaches infinity. So if you want to know why Ramanujan should be called the man who knew infinity, because from this perspective, together with Hardy, he came up with an almost correct formula. It wasn't correct, but the closer you get to infinity, the closer it achieves perfection. And yeah, I gave a little speech like that, and I think people liked it. So not only is it a poetic statement that Ramanujan knows infinity, it's a way of poetically trying to describe perhaps his most famous theorem with Hardy. Now, to a mathematician, these numbers, this theorem is very important, not just because of the statement of the theorem, but because it also it marks the invention of a method that has been applied to many different kinds of problems in mathematics. It's called the circle method. So although you may not be interested in the partition function itself, I assure you the circle method has been applied to a wide range of problems in mathematics, and my guess is that some of them would speak to you. And this theorem also marks the inspiration of a lot of my work, for example, in connection with the Mach theta functions. So what do we learn from Ramanujan? Again, the talk was called Why Does Ramanujan Matter? And I think I've given a number of answers, and I hope all of them speak to you. But at the very least, I hope some of them give you reason to pause. So the mathematician in me feels compelled to give the first answer first. What do we learn from Ramanujan? We learn a huge amount of mathematics. So it's not just about the partitions. I wanted to talk about the partitions so you could see an example of a theorem in real life, and also learn why we should be calling him the man who knew infinity. But if you go beyond that, Ramanujan's legacy is breathtaking. So people have won Fields medals for figuring out Ramanujan's mathematics. A Belgian mathematician by the name of Pierre Deligne won the Fields medal for solving what were called the Weil conjectures. The most difficult of the Weil conjectures was inspired and includes as a case a conjecture Ramanujan made in a paper in 1917. If you're interested in abstract algebra, the classification of groups, what we call the classification of finite simple groups, there was a very difficult group that people discovered called the monster group, the largest of the sporadic finite simple groups. I don't want to go into what that means, but there is this largest group called the monster of a very special type that mathematicians had a difficult time constructing and still have a difficult time understanding. A very famous English mathematician by the name of John Conway and his collaborator Simon Norton conjectured that this group could be tamed, could be studied by what are called modular functions. And this claim was proven by Richard Borchards, and it won him the Fields Medal in the late 1990s. Perhaps the most famous theorem proven in number theory is the proof of Fermat's last theorem by Andrew Wiles in 1995. The method of proof involves what are called Galois representations that another Fields medalist, Jean-Pierre Serre, theorized existed because he wanted an explanation for congruences that Ramanujan had found decades earlier for a function called tau of n. So Ramanujan found these beautiful congruences. They're among my favorite theorems to describe for a function called tau of n that he was able to prove through magic tricks. Ramanujan was a wizard with formal power series. And what Serre, the Fields medalist in the 1960s, discovered is that what Ramanujan's tricks gave a glimpse of was a large theory, a theory involving abstract algebra, the representation theory of Galois groups, stuff that Ramanujan had never thought of. And it turned out that the theory that was developed to explain Ramanujan's congruences is now the stuff of modern arithmetic geometry, and its first huge result, I would say, was the proof of Fermat's last theorem. So without Ramanujan, there would still not be a proof of Fermat's last theorem. What else do we learn from Ramanujan? Well, if you're not a mathematician, you might not appreciate prize-winning works. But I think there is science that you can deeply appreciate. So my friend P.P. Vaidyanathan, he is an electrical engineer at Caltech. In 2016, he won the Kirchhoff Award in signal processing. What is signal processing? It's a major field at the interface, at the confluence. So Sort of like where the Ganges comes together. There's a confluence of rivers, if I get this right, near Allahabad. There's a very famous math institute called the Harish Chandra Math Institute, not very far away. There's a confluence of ideas there. It's a very spiritual place. And in mathematics and in computer science and in electrical engineering, you have a similar confluence where Ramanujan plays an important role, and it's the field of signal processing. This is the stuff of information, communication, exchange. So when satellites communicate, right? When you communicate over the internet, your information is transformed into signals that have to be transported long distances and decoded for a receiver. So I'm not talking about cryptography or cryptology. I'm just really talking about the mechanism of information transport, the signal processing. Errors are introduced when satellites beam up and receive messages. Errors are introduced all the time. The world is not a perfect place. So signal processing is the engineering and the mathematics that's designed to eliminate these errors. And P.P. Vaidyanathan discovered that in certain wavelengths, a certain kind of mathematics was needed to optimize this kind of science. And he said, we need a kind of mathematics with these key features. And he only discovered later that already in Ramanujan's writings, these features existed. They come in the form of functions that are called Ramanujan sums. And when Vaidyanathan learned about these sums, he was able to put them to use almost like you would input, a cartridge into, some device that just needs a working piece. And he won the Kirchhoff Prize for recognizing that Ramanujan's mathematics could solve a problem before the problem even existed, right? When Ramanujan was living, nobody was talking about satellite communication. Nobody was talking about signal processing, but lurking in his works were these Ramanujan sums that already solved the problem that Vaidyanathan would systematically develop over 100 years later. So as I begin to wrap up, and I have a very special video at the end that I want to share with you that I hope you think is special. I've never shared it in a webinar before, at least not to my recollection. Let me share with you what I think is a poetic description of what the idea of Ramanujan should be moving forward. So in addition to the answers to the questions I've offered, why does he matter? Let me share with you the idea. This is in an article I wrote with my PhD student, Robert Schneider, who is now a professor at Michigan Tech. You see, Ramanujan matters because he represents endless curiosity and untapped potential, which we all have to believe in to proceed in the sciences. Science usually advances on the work of thousands over generations, fine-tuning and extending the scope of understanding. But from time to time, creative fireballs like Ramanujan burst onto the scene, propelling human thought forward. And I think in all of the answers to the question I began this lecture with, Ramanujan offers that. He propels human thought forward for students so that they recognize that education is not the mindless stuff of tests and examinations. He speaks to policymakers when policymakers have to recognize, how do we go beyond the boundaries of existing structure to help science move forward? Of course, the mathematics is there. And so I would like to support this as the idea of Ramanujan. For a number of years, I've used the story of Ramanujan to support a global search for talent worldwide. It's called the Spirit of Ramanujan Global Talent Search. And I don't want to tell the full story here, it's quite long. But let me say, the making of a film is quite difficult. We secured financial assistance from many sources, including the Breakthrough Foundation. The Breakthrough Foundation is headed by Mark Zuckerberg, Facebook, Yuri Milner, Jack Ma. They helped us out quite a bit. And when the film was completed, we screened the film for them in Silicon Valley. We screened the film for them at the end of a conference that they were running supporting SETI, which you might know about, This is a search for extraterrestrial intelligence. And at the conclusion of the screening, I was asked to come on stage and give some closing remarks. And I don't know what came over me, but I sort of took advantage of the moment because everybody in the audience was searching for extraterrestrial intelligence. And I said something like this: just like you guys, SETI, seeking extraterrestrial life, I think we must search the globe, planet Earth, terrestrial life. We must search the globe for undiscovered scientific talent. We must locate and nurture this undiscovered talent. We should be looking for the Ramanujans, because try to imagine where we would be today had he never been brought into the light. Not only would there not be this film, all of the things that I've just described to you would not be our reality. So at the conclusion of that screening, the president of the Templeton Foundation came up to me and said, "You are right." And with his help and that foundation's help, we have been giving out small grants to budding scientists around the world. And that is the spirit of Ramanujan global talent search. So here's yet another reason why Ramanujan matters, because his story inspires philanthropists, people with means to do good things, to help out those who don't yet have the opportunity, might not have the luxury or the ability to be brought into the light. So I'd like to conclude this lecture with a featurette. It's about 4 minutes long, and it's, I appear in it, but only briefly. You've heard enough, I think, from me, but I want you to hear from some of the top scientists in the world about what they thought about Ramanujan. Both, well, not just the scientists, the actors and top scientists about Ramanujan. I told you why I think Ramanujan matters, and I want to share with you a 4-minute featurette explaining their answer to that question.
Ramanujan was an Indian. He was, in a way, my discovery. I did not invent him. Like other great men, he invented himself.
The Man Who Knew Infinity is the title of the new film about Ramanujan. Of course, in the mathematics community, his story is very famous, and mathematicians have always wished that the rest of the world could know about his incredible story. But also, it's the first film that sort of accurately portrays how mathematicians view their subject as an art and as a pursuit of beauty and as a pursuit of elegance.
Ramanujan flunked out of college. He was working as a clerk in a port in Madras, and he had written out of the blue to Hardy, and the story of the movie is about his interactions with Hardy, and that led to some great mathematics.
It was a story about mathematics, something which to me seems entirely passionless, but it does contain passion and wonder and mystery and art.
The mathematics is incredibly difficult to grasp, if not impossible for someone like myself. We had a really amazing guy called Ken Ono who guided us through the complexities of it all, taught me a couple equations that I could write out lightning fast.
I had to give a special practice lecture. What does it look like for me to give a math talk? Because they had never been to any math talks before.
It is a beautifully dramatic recounting of a relationship that is one of the most important in mathematics within the last 150 years. And this movie has real significance for conveying to the public the doing of mathematics and the emotional element.
All right, now, are you following this?
Yes, sir. Most excitedly.
Well, you don't appear to be taking any notes. Is there something you'd like to contribute?
Ramanujan went into a course on elliptic functions, went to the board, and he went on to do later material that would be done. And the teacher wondered how he had learned all this material, not knowing that he had in fact discovered a lot of it on his own in India.
How do you know? I don't know. I just do.
My whole career has been very largely based on this famous paper which is depicted in the movie on the partition function. And for me, this movie is a very emotional thing because I'm seeing depictions for the first time, really, of people who played an important part in my whole life.
Major, can I have a word?
I don't have time for you.
Partitions. It's Ramanujan.
The movie did a very nice job through Major McMahon of capturing the surprise in this partition function formula.
Can't be done, I'm telling you, especially not by you.
Only Ramanujan, with his excessive optimism in mathematics, would have believed that such a formula existed, but it did.
Ramanujan's mathematics is so breathtakingly beautiful that it can actually be used to not only inspire young people, but also get people attracted to the subject itself.
I think Ramanujan was, in a way, rather like Mozart. I mean, that mathematics was just something so natural that he had a gift, which is something miraculous we don't understand.
And there you have it. That's my presentation, everybody. Thank you for listening.
Thank you so much, Professor Ken Ono. Truly, it was mind-blowing and so many information, but you presented everything in a most nicer way. So now we have a little bit more time. So would you be able to do a little bit of interactive session now, sir?
Sure. For a few minutes, I'd be happy to.
Okay.
Yeah.
So hi, participants. If you have any questions or something interesting or something nicer to mention, this is your opportunity to talk to Professor Ken Ono. But please make sure nothing is interrupted. Wait for your call. Please try to speak with your video on, and also please introduce yourself while you do that. Okay, so so many texts in the chat box, but yeah, if you have any question, we could wait for a few minutes, or otherwise we will move to the
I think there are a few raised hands, but I don't know how to call on them.
Okay, so people who raised your hands, if you have any question, please ask, or otherwise please unraise.
So, yeah.
Can I ask, sir? Good evening, sir. My name is Shubham Jha, and I want to pursue, sir, applied mathematics because I believe I want to do research in computer science. So, do you think that my choice would be great since you have been a professor of mathematics all this long? So, I want to pursue in computer science research, sir.
So I'm not quite sure what the question is. I invite you to pursue a career in computer science. Computers are everywhere. You'll probably want to become an expert in machine learning, large language models, right? In North America, I can speak from some experience. Job opportunities, the number of jobs offered in data science and computer science along these lines has grown over 30% each year for the last 3 years. And I'm fairly confident the same is true in India. So yeah, going into computer science with an eye towards these directions, there should be many opportunities.
So would applied maths would be a great choice, considering masters in applied maths and then PhD in later in computer science?
Well, I kind of hesitate to talk about getting different degrees because at the end of the day, it's your credentials and the skills that you develop. So I would hope you could find institutions where you could both pursue your applied mathematics and computer science simultaneously. That should be possible.
Right. So
but if not, that sounds reasonable. Not having experience in computer science I have to recommend that everyone have some experience in computer science. I think that's
undergraduate in computer science, sir.
Pardon me?
I'm undergraduate in computer science, sir.
Great, good. So you know how to learn algorithmically. That's important. Yeah.
Yes, sir. All right, sir. Thank you so much, sir. It was a pleasure, sir.
My pleasure.
Sorry to interrupt.
Good evening, sir. Good evening, ma'am.
Sir, there is a question from me, and I want to know how quantum computing is closely related to mathematics. So that is going to.
How is quantum computing related to mathematics? Oh, geez, I don't really know how much time we want to spend on that. So there are two aspects. First of all, there's the theory that goes into designing a quantum computer. That's quite mathematical. But I think perhaps the most important answer will be how quantum computing will revolutionize how we carry out certain kinds of mathematical calculations. Perhaps the most famous example is primality testing and factoring integers. If we have a robust and accurate quantum computer, the present algorithms that run on a conventional computer for factoring and primality testing would be all instantly obsolete. And there are many other problems in mathematics where this phenomenon will be achieved.
Thank you, sir.
Hi, sir. Good evening, sir. Yeah.
Okay. Yeah.
Yeah. Hi, sir. Mandeep here. Sir, I wanted to make a couple of observations and some suggestions as well. One of the observation was that I think you had mentioned that Ramanujan had learned the trigonometry by himself.
Yeah.
What I had learned was that probably he had championed the Apollonius books by the age of 13. So all by himself. Yeah. And so the other things I just wanted to also share was that there is also a biographical movie on Ramanujan in Tamil.
I've seen
local language.
Yeah, I've seen that. Yeah.
Yeah, which is also a very, very emotional and a very nice movie. So that's also something to be told to the world about. It's also a very nice one.
I don't know how to. The only time I saw that film was on a laptop that my friend Sujata Ramdorai, she's a professor at the University of British Columbia. That's the only time I saw. I don't know otherwise how to access it. Yeah.
Okay, it's on YouTube. You can access it.
It's actually on YouTube. Oh,
it is on YouTube.
Okay.
You can watch it with the subtitles.
Okay. Maybe everything's on YouTube now. Okay.
Yes.
Okay.
So and so just one more thing also was that on your this project of in the spirit of Ramanujan, what I tried to learn a bit about it, and what I could not see was that is it actually a platform for guys like Ramanujan? Because to me it seemed like it is more for students, but not actually like guys. Yeah.
So here's the thing. Ramanujan is so rare, right?
Yes.
So going back to what I began the lecture with, his story is inspirational to people, and so most of the recipients of our little grants have been students who otherwise would be unable to participate because of finances or distance in activities. So yeah, but make no mistake, maybe we haven't discovered a Ramanujan yet, but we have discovered some truly amazing individuals. We discovered one girl from a small village in China who ended up going to MIT on full scholarship. She graduated in MIT in 3 years, ended up winning what's called the Morgan Prize and the Schaefer Prize in the United States, the most elite prizes for undergraduates in mathematics. She graduated MIT in 3 years, then won a Rhodes Scholarship, where she studied at Oxford with James Maynard, the Fields medalist, and now she's at Stanford, pursuing both a PhD in mathematics and a law degree at Stanford. And we have, so this program, I think, has many success stories. Will anyone rise to the level of Ramanujan? Maybe not, but I don't think that's a negative.
No, sure. I understand, sir.
Yeah.
Thanks a lot for the talk. Thanks. Good evening, sir.
Good evening.
Good evening, sir. Myself, Madan Beniwal. I am working in central government services. So, sir, my question is, how we can promote mathematics at all levels, at the basic level, class 1 to 10th? How can we promote?
Yeah, so this is not my expertise. So my first inclination is say, please keep trying, right? You know, I don't know how true this is in India, but young students in North America are, you know, addicted to things like TikTok, social media, right? So assembling short and exciting videos showing the beauty of mathematics may go a long way. But like I said, this is not my expertise.
Good morning,
Thank you,
sir.
sir.
Good morning.
So, sir, I was reading about knot theory recently, and I was wondering if Ramanujan's works help somewhere in letting us know about the equivalence of knots. I mean, do they have any
Okay.
relevance with the knot theory?
Oh, that's an excellent question. And wow, I have a student finishing her PhD in May. Her name is Eleanor McSpirit, and she's actually working on what are called quantum knot invariants. And the main new mathematical tool in her work are new families of quantum modular forms, which are inspired, in fact, by Ramanujan's Mach theta functions 100 years ago. So yes, so the question about using Ramanujan's mathematics to determine whether two knots are equivalent, maybe for that precise question, no, but for the field of knot theory, absolutely yes.
Thank you, sir.
Hello, sir.
Hello.
I'm Gayatri. I'm from Kerala. I'm really happy and grateful to be able to listen the amazing story of Ramanujan, and the talk was incredible. And I would like to add one thing, that I got a chance to visit Ramanujan's home in Kumbakonam, and I could really experience the legacy he left behind. And thank you so much for sharing a lot of information with us, and thank you so much for your time, sir.
Oh, my pleasure. My pleasure. Everybody should go to the museum in Kumbakonam if you can.
So, sir, I have attached the link for the movie in the chat
Oh,
box.
okay.
in case
Thank you.
want.
Thank you.
Greetings, sir.
Yes. Hi, how are you?
Sir, I'm Praveen. I'm from Kerala. I'm fine. Sir, as you said, and as it is mentioned in the film, Ramanujan did not give much focus on proofs. So, as a mathematician, do you think like giving proofs is important, or should the focus be more on proposing various conjectures?
Oh, you can't have one without the other. You know, some conjectures are very easy to make, some are very difficult to make. And so, and some conjectures that are made are wrong. So the necessity of proof, justification, that will never go away. But in Ramanujan's case, I want to stress that the conjectures and formulas that he found aren't the simple kinds of conjectures one might make just by computing lots of examples. He had this talent for finding phenomena in places where nobody would expect them. And so, yeah. So for your question, you need strong conjectures, you need strong inspiration, but you also need the ability and technology, theoretical as well as computer now, to confirm them. They both are required.
Yes, sir. Thank you.
Hi, sir.
Hello.
Hello, sir.
Oh.
I am from West Bengal. I am
Nice to meet
Manatas
you.
Mandal, assistant professor in mathematics. But I have one emotional question. We Indian have lots of mathematics, yeah, but
Yeah.
actually we don't know anything about them. For example, Siddharacharya, the formula we used to find roots of quadratic equation, but we don't know anything about him. There are lots of mathematicians. What 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 is the reason behind it? We Indian, but we do not know anything about our Indian mathematicians. What are the reason you think?
Wow. So, history. So this is less a question about mathematics than it is about history, right? At the time you are living, you might not recognize the important things that are going around you, and then when time goes by, information is lost. Here in the United States, maybe you're aware of this. Some of you might be aware of a very famous movie called Hidden Figures that came out maybe 4 or 5 years ago. And it's a story about African-American women mathematicians who helped the US space industry, helped send people into space. That history was almost lost, and that was in the 1960s. So I think keeping records and recognizing great people before their stories are lost is just a problem with mankind. Yeah.
Thank you.
Yeah. Yeah. So I'm sorry, I need to go here soon. Maybe one more question.
Yeah.
Sure.
Okay.
Yeah, the whole lecture was amazing and I enjoyed it thoroughly. But one thing that very much intrigued me was that the partition formula. Okay, means it looks so beautiful, and means how did he come up with such a formula? Okay, how did he means go beyond the basic understanding of what the function does, and how did he investigate the function? I want to know.
Oh, all right. Okay. So this is not a quick answer. Have you taken a course in complex analysis? Do you know Cauchy's integral? Do you know about?
I actually just passed 12th grade high school. Okay.
Okay.
And I'm not currently enrolled in college yet.
Okay.
Okay.
Okay. So let me say that there was a very important mathematician, French mathematician by the name of Cauchy. And are you familiar with calculus?
Yes. The basic computational calculus in high school that I'm familiar with.
Are you familiar with the theory of Taylor series?
Yeah, the means Taylor approximation, those polynomials, just I know. The derivations I do not know.
So if you remember that a differentiable function in calculus can be expanded by a Taylor series, where each of the coefficients in order are essentially the higher order derivatives of your function. So in complex analysis, there's a very similar theory called Cauchy's integral formula, where you can expand a function as an infinite series, an infinitely long polynomial, where each of the subsequent coefficients can be used by inverting this idea of Taylor, by computing integrals of some functions. So there's something called Cauchy's integral formula that can be used to compute the coefficients of the partition function when you recognize that the partition numbers are coefficients of a function that fits into that theory. That's probably the best I can offer you right now.
Okay.
Yeah.
Thank you, sir.
Thank you,
Okay.
everyone. Thank you, participants. Thank you, Professor Ken Ono. So without any delay, with so much love and so much gratitude, I'm moving on to the vote of thanks session. So I'd like to welcome Shikha Kumari from Birla Institute of Technology, Misra, for a very quick vote of thanks for our chief guest today. And thank you once again, sir.
My pleasure.
Thank you, Arjuna. Am I audible?
Yes, you are.
Thank you. Good evening, all. As we conclude this enlightening National Mathematics Day webinar, I, Shikha Kumari, on behalf of the organizing committee, would like to convey deep regards and hearty thanks to our distinguished speaker, Professor Ken Ono, from the University of Virginia, USA, and associate producer of the Hollywood film Ramanujan, The Man Who Knew Infinity. Today, his insightful presentation have enriched our understanding of the world of mathematics. I extend our heartfelt thanks to Emeritus Professor Ambat Vijay Kumar Sir, CUSAT, Kerala, India, for introducing the speaker and gracing us with his presence. I would also like to express my sincere gratitude to Dr. Vinod Kumar Sir, Associate Professor, TMG College, Kerala, India. Dr. Bijumon Sir, Associate Professor, MG College, Kerala, India. The host of this webinar, Ms. Arjuna, and the whole organizing committee for their meticulous planning, tireless efforts, and dedication in ensuring the smooth execution of this webinar. To our participants, thank you for your active engagement. Thank you once again to everyone who has been a part of this event. Your collective efforts have made this 10th National Webinar on National Mathematics Day a resounding success. I wish you all continued success in your future endeavors. Thank you so much.
Goodbye.
Bye. Thank you, Shikha. Goodbye, sir.
Goodbye.
Thank you, sir.
Hi, sir. Good night. Thank you, sir.
Thank you, sir.